Is it working? All right. So I don't know how many of you have actually used Git, but I'm going to start from basics, considering you've never used version control before. So it's a specific implementation of version control, but there's many ways you could do this. The common way for a lot of people is basically you work in a directory, and when you want to make a release or a version of it, you just copy the directory and start working in a new one. But I'm going to try and explain why that's probably not a scalable solution to the problem. So basically, Git helps you manage arbitrary revisions to files. So if you change a file, you can always get back to an old version of it. So that's basically what I'm talking about here. I want to say it's different than versioning for software. So if you have like a release cycle for something like Firefox where you have 30, then 31, then 32, that's not quite the same thing. You can do something similar to that with Git and other version control, but that's not what I mean. I just mean any change you make to any file, not a whole project release. So like I said, you can take your project directory and then just copy it every time you want to make a new version. But that only gets you history. So being able to go back to an older version of a project. There's a lot of other things that Git is good for. So for one thing, all the releases or all the revisions to the files are verifiable. So what it means is your history is locked in and there's no way for it to change without you noticing. The big one that we talked about a little bit was collaboration. So if you want to work with somebody else, it becomes a huge pain to just send them a whole copy of your project every time you want to make changes. And sharing patches doesn't work either. It doesn't work well with more than a couple people. And finally, stability, because if you want to release a real project out in the wild, people are going to get mad if you're constantly breaking it. So you want to have a release version of it where things are always stable. And Git helps you do that too. And also, anytime anyone has any questions, just let me know. Yeah, Magoo.
When you first started, it said git-scm. Is this different than GitHub?
Yeah, the question was the website for Git is git-scm. The difference between Git and GitHub is Git is the software, and you don't need a server to use it. You don't need a service. It all happens locally. GitHub is just a way to collaborate with people. So it's like a cloud. Yeah, so it's an intermediary for you to do collaboration. It's a special type of a Git repository. I think I might go into that a little bit more, but if I have more questions about that, that's a big one because a lot of stuff happens on GitHub. But there's a difference between Git, the software, and GitHub, the service.
Imagine working without a versioning software.
Yeah, a lot of
Almost always the projects end up developing their own because it's just so important.
Yeah, you can get by without version control for a while, but that doesn't last that long. So the first question after you've accepted that you should be using something like Git is how you would use something like Git. So just the general formula for everything, there's one command called git, which is the actual executable you're running, and it dispatches to all these subcommands. You could call them verbs. So it's always git, then the special command to git, and then all the options to that command. Some of the ones you might see are clone and add and commit and push. There's a ton of them, but you only need a few to get started. So basically the workflow using Git is you work on the files. So you open all your files in editors and make changes. You add all the files to something called an index or a cache, which I'll go into a little bit later. And then you commit the changes you've made to a commit object so that it stays in the tree forever, so you can always go back to it. So, so here's an example. I'm just going to run through an example of just maybe creating a Git project. So let's say you wanted to start working on a project and you don't have anything yet. The first command you might want to learn is git init, which git init, if you give it a directory name, will create a Git repository for you with nothing in it. So it says it made an empty repository for me. So I can go in there. And another command that you're going to use a lot is git status, which it's an overview of what's the current state of the repository. So if you've made changes but you haven't committed them, they'll show up here. So for example, if I make a file and then run git status again, now it's telling me that these files are untracked. So Git has never seen these files before at all. The next command you might want to learn is git add. That puts it into something called the cache, which I'll go into later. And anything that's in the cache gets committed when you run git commit. And you can pass it, you have to have a git commit message. So you can ignore some of this here. There's some errors because I haven't set up some configuration. But basically it succeeded here. It added one file changed. Now, if I run git status again, everything's clean. Now let's say I edit the file, run git status again. Now you see it's modified. So basically this is Git tracking all of your changes. So you've made a change since the last time Git knew about it. So it's letting you know that. You can add it again the same way you did before. And you're clean again. Now I'm going to go into this a little bit more later, but there's a command called git log. Those are all of the commits you've made on the current branch. And this is a horrible way to look at this. There's a way to look at it as a tree. So you can do...
The tree.
Yeah.
Looking at the git, looking at the git log, is that only for things that you've committed personally, or anyone that's committed?
So the question is, because you can collaborate with Git, is this log only things you've done, or all the things in the entire repository? So any changes you pulled in from somebody else. What this is actually the current branch you're in.
Okay.
So you can have other branches from other people that you maybe don't have checked out. The verbiage for it is you have the branch checked out. This is what your current checked out branch is. I'm going to go into this a little more too later, but this is just all of the things that led up to where you are currently, how you got to exactly where you are. You can actually use, you can do, I don't have enough history in this one to do it, but you can actually specify different parts of the tree to look at, so you could look at a different branch or other parts of the tree. But this is basically, if you're only working by yourself, this is everything that's ever happened. Is that?
Yes.
Okay, yep. So that's basically all I wanted to cover right there. So that's just kind of an example of how you might use it just by yourself. You can just, every time you want to save a version, you add everything, that's a one to know. Git add -A. That adds everything that could possibly be added in your current directory and below it. So if you always just use git -A, git add -A and git commit, then you would at least have a history. Oh, Partisan.
Is there any reason you don't want to do git asterisk?
It won't add, or actually it probably does. Some of those commands won't add untracked files, so for the first time you add it, but I'm not actually sure if there is a difference.
Maybe you don't want to add all the files in your directory.
That is true. You're going to find that...
In place of the -A.
Git star won't properly add files or files inside of folders. Yeah, but that gets recursion. It does do recursion.
It might be equivalent.
Star should just return, it should just, the system should just, if you're in Linux, it should just interpret that as a file.
This sounds like an edge case.
So it just add,
Yeah.
it can take more than one file at a time, right?
Yeah.
So no
So
subset.
there you go.
This sounds like a weird edge case.
Yeah.
You can... I'm not an expert on Git by any means. I've always used -A. There's probably you can use star, but however you want to do it, you have to be able to run git status and see that every file you're interested in is under changes to be committed. Then when you do the commit, all of those will be added to the commit. So however you get that done. So you could just use this just locally. Basically no setup. You do git init and then you can just get history, and this is kind of a cleaner way than doing the copy the directory every time you want to save a version. It's a nicer way to do it. So, but I kind of glazed over the whole cache index thing, how you have to add a file first and then commit it. This doesn't affect most people at the level of a small project. You usually just want to commit everything. You don't have too many times where you want to add some things but not other things and commit in weird ways and all these things. But Git allows you to be flexible about it. So it has something called a cache or index, which sits between the work that you're actually doing, so the working directory where your work is that you can see and work on, and the repository, which is all of the history. So you can move objects between three places, basically. There's a working directory, which is what you know. It's just the files. You can actually look at them. They're actually there, just as you expect. Then there's a staging area called the cache or index. When you make a change and you add it, what you're really doing is making a reference to that file in that current state. You're making an object in something called the cache. And when you commit it, you move it into something, the repository, so it's saved forever. In the cache, it's kind of volatile. It might change. You can add things, remove things, and figure out what you want to commit. And then when you do the actual final commit, it moves it into the repository. So you can check out things from the repository into your working directory. When you want to look at a different bit of the tree, you might check out a commit or check out a branch or something like that, and it'll update the files you can see and work on. When you want to make a change, you add it to the cache or the index. And then when you want to actually save it as a commit, then you commit it from the cache to the repository. So when you do commit, it doesn't look at your working directory at all. So if you've made changes since the last time you've run add, they won't get committed. Only the stuff that's been added first. Thank you.
I thought we were trying to check out Trinary.
Yeah, check out Trinary.
Check it out, man.
So I think this trips people up one of the most out about anything, because people might make changes and then just run commit. And if they haven't run add yet, there won't be any changes committed. They'll still have a dirty working directory. It won't get saved. So that's something to be wary of. You need to make sure that you put it in the staging area first, and then you commit it to the repository.
That's probably because a lot of people come from Subversion where there's no intermediary.
Sure. Exactly. Yeah. So this is a Git thing. There's probably other version control systems that do, but yeah. For example, SVN doesn't have an intermediary cache and index. Yeah. Good point. So I kind of threw around the terms files and objects and commits. Basically, everything in Git you can think of, you can call it an object. There are different types of objects. You have a file in your working directory. You have an object in your cache, and then you have a commit object in the repository that tracks everything. But the thing that I'm trying to get across in this is that commit objects are completely immutable. Once you make a Git object, a commit object, Git will never touch it. So you don't have to be afraid that you're gonna really erase history. You can never really erase history in Git. When you make there are certain commands that might pretend to like rewrite history in a certain way. They don't remove the old commits. They add new commits that look like the old ones. And if you really want to, and it's not that difficult, you can get back all of the old commits if you make a mistake. The one thing you can't get back is anything that's in your working directory. There are commands like git reset, which will pull in commits at a certain point. It'll grab files from your past, from the history, and overwrite your working directory. If you haven't saved the changes to a commit, it's fair game. They could be completely erased. So if you worked for a month without making any commits and then accidentally reset, it would just trash it all, and you would have no way to get back that information. So the moral of the story here is commit early and commit often. So just, even if it's a small change, add the file, commit it, and then you don't have to worry about it because you couldn't possibly lose it anymore.
The first time I ever used Git, that's exactly the thing I did.
Yeah?
Yeah.
You lost everything? Yeah. Yeah. It's very easy to, especially if you're... Yeah. The thing is, once you want to get stuff into a commit basically as early as you can and as often as you can, because once it's in a commit, you can be perfectly, there's no way to get rid of it. Git will never get rid of it. I say that, but for practical reasons, because if that happened, the directory would just keep growing in size. After a month, if you haven't touched a commit in a month, it will get deleted for you, because you basically, Git assumes you've forgotten about it completely. You wanted to basically delete it. Yeah.
Even if it's the most recent commit you've made?
The most recent commit you said even if it's the most recent commit. So if it's visible in the tree in any way, like if there's a branch pointing to it or it's visible in your tree, it will never get garbage collected. It will always be there. But for example, let's say you change a commit message. There's an amend command to commits where you might want to change a commit message. The way that works is it makes a new commit with all the old information, and all it changes is the commit message, and it points that's where you are now. The other commit sits there, but it's not referenced by the tree. You can't see it in any of the normal commands like git log or anything. After 30 days, that command will disappear. But I don't know what you mean by most recent. It's 30 days from when it becomes invisible, I believe.
So I guess maybe I'm not understanding how things get lost and things don't get lost.
So what I don't know if I kind of go into the tree thing a little bit later, but the way that the Git repository works is there's a root commit that doesn't have a parent. It's just the state the first time you used Git. And then every other commit points backwards. It has a parent. And it makes an acyclic tree that goes out from that root. At any given time, you're just on some node in that tree. And so you have a full history back to the first time you added anything to Git. If the commit is in that tree anywhere, referenced by anything else, pointing back to root, it won't get garbage collected. If it's not in the tree, like if it's just out on its own, some part of completely separate commit, then it will be garbage collected.
How does that happen?
Like I said, if you amend a change onto a commit, it forgets about the old commit, makes a new one. But it doesn't delete. What I'm trying to get across is here, it doesn't immediately delete the old commit. it leaves it there, and you can get back to it. There's tools to find it. But at some point, it cleans it up, is all I'm saying. You can basically pretend like there's no garbage collector, and it'll never be a problem. But after 30 days, after a month, if you haven't touched something, it'll go away. But as long as it's in the tree, as long as you can see it, it'll be there forever. Okay, so the next little bit is more important for if you're using this in a collaborative way. So it's distributed in that everybody has a full copy of the repository. So like SVN, for example, it has one repository on a server somewhere. And anytime you want to work on it, you have to connect to it. So if you're on a train in the mountains somewhere trying to work on your code, you can't commit anything because you can't connect. You can't do things like diff. You can't check the log. You can't check any of the history. There's a lot of things you just can't do because SVN is centralized. Git is nice because it's distributed. So you don't even have to set up a server if you want to use it. Like I said, like I did there with the Git init, and I just started working. I didn't have to do any server setup. It just started working immediately. But if you do want to work with somebody else, you can use a service like GitHub, which acts as an intermediary. So GitHub has a full copy of the tree. You have a full copy of the tree, and somebody else has a full copy of the tree. The normal workflow is you push a change to GitHub, and then the other person can pull the change from GitHub. So that's what some of these verbs are here. For example, if you wanted to start working on a project, you would clone the repo, which creates a local copy of it. So here, for example, I'm going to clone the repo for this presentation that I'm doing right now. I wrote this presentation in Git. So I used GitHub as a service to host it. And I think I remember okay, here we go. So what it did was went out to GitHub and asked, hey, do you have a repository called gitmdp? I'd like a copy of it so I can work on it locally. GitHub said, yes, of course I do. And I pulled down a copy of the entire thing, all of the objects. You can see there were 68 objects total. So here is the presentation in text form that I'm giving right now. But I didn't do it all at once, and I kept track, basically one commit per slide. So you can see the log of all the changes I made while writing the commit, the times I did them, all that stuff. And for example, if I wanted to make a change, add a new slide, you can see it's modified. So I add it to my cache. It's ready to be committed. Oh. Bit of a mistake there, but doing it live. So I added the commit, so now I can see there's nothing. I'm actually ahead. So here is where the remote comes in. It's tracking the fact that I first cloned it from GitHub. So it actually asks GitHub, or actually it doesn't actually ask GitHub here, but it has a local copy of the GitHub version of this tree. And it sees, oh, you have one more commit than GitHub does. So now, for example, if I wanted somebody else to look at this, I could use git push. And I'll explain what these words at the end mean here later. But origin means GitHub, and master means the normal current branch that I'm on. And then it's going to ask me to log in. Now there's a copy of that commit I just added up on GitHub. And for example, if somebody else wanted to work on this, I could just say, go to GitHub and clone this repo, work on it. And then we can both work independently on our own machines. I'll make as many commits as we like. And as we push up to the main repo, we can pull from each other and see what each other are working on seamlessly. Working all on one branch is a problem sometimes, not all the time, but there's a mechanism called branching which makes this even easier. And I'll try and cover it a little bit later, but that's kind of too much for most of the stuff you'll be doing in the beginning. So basically all I'm saying is GitHub is a place for you to put code that you wrote using Git. And it's a really nice service. You can use it for free, and you get all unlimited repos as long as you don't place any restrictions on who can see it. So that's basically the distributed thing. So remotes. When I wrote origin and I said it meant GitHub, when you do the clone, Git automatically adds something called a remote for you. And the normal name for this is origin. And you can see origin points to github.com/ it's the place that I cloned it from. So if you want to push back changes, you don't have to write out github.com/ you don't have to write all that out each time. You can just say git push origin. Now the other bit that I didn't explain was master. master is a, okay, so I just did this. That is a little example. Master is a branch. Now, this is going probably beyond, if you're just getting into Git, you don't really need to learn about branching right now. You could just use it locally just to keep track of your own changes. You don't have to use anything other than master. So all you need to know is master is a branch. You can just use it always. You don't have to worry about it. But I want to cover it a little bit because Git does branching really well, as opposed to a lot of other things like SVN, which do it very poorly. But there's always at least one branch, or basically always. You can actually probably have no branches. But one branch called master, which is where all of the, which basically is the current project as it is. You can have other branches where you're developing, but master is the project. And for example, if you just check out master and you make one commit, so let's say you just initiated a repository, added one commit. This is what the diagram of the repository looks like. The A is a commit object, master is a branch. And all the branch does is point at A. And I can actually show you this, hopefully, here. So the branch is actually just a file in .git, which .git is the special repository directory, the special directory that signifies that this directory is a Git repo. And it just has information, that metadata about your repository, and all of the commits that you've ever made show up in here somewhere. That big number right there is a SHA hash, which is just a unique way of identifying a commit. Because a commit is immutable, you can actually just represent it as a hash of its content. So there's no special name for commits or anything, but they are uniquely identifiable just by the contents. So if I do git log, it starts with D397. That is the current commit. If you look at the top, the head of master is my where I am currently. So just recognize that a commit exists somewhere, and a branch is just a pointer to a commit. Now let's say you make a new commit. The branch, or the commit points back. It has a parent, which is the old commit. And that's what I meant by the tree. So there's a pointer back to one of its parents. And what Git does, because it's so nice and does this for you, is it just updates the master pointer to the new one. So as you move along, the branch follows you as you add new commits. Then let's say you add a new commit, or you add a new branch. By default, the branch will just be wherever you currently are. If you're on master, it'll point to the same place. I just called the branch feature here. So there's two things that are both pointing to the same commit. So it's kind of redundant right now, but as you add a change, only the branch that you currently have checked out gets updated. So for example, let's say somebody else is working on master and you don't want to disturb them while you're working on some unstable feature or something. You make a new branch and then you work on that, and you don't disturb master. So everybody else can keep working as if you're not working. So this is why it's really great for collaboration. Let's say the other person updates master and you pull down their changes. Normally it would be a big problem because their commits might conflict with yours and you would have a problem and you have to merge it. As long as you're on another branch, it doesn't affect you at all because you can just let master keep walking next to you. Now let's say you add another commit. Again, you're only updating your own tree. Now let's say you want to finally merge the feature back in. You can use what's called or the command git merge and say what branch you want to merge into your current branch. So if you're on master, you do git merge feature, and it will pull in the changes from both branches and make a new commit. Now, this is actually not 100% true. There's two ways. It can actually, I'm not going to say it here, but I added the flag noFF. It just makes it simpler. It makes a merge commit from the two branches. So you made one commit on a single branch, made a new branch. New commit doesn't affect the old branch. Commits on the old branch don't affect the new branch. And you can keep doing that as long as you like. And when you're ready to add your feature back into the main version of it, you just merge them. And now they both point to the same thing again, so you can delete the old one. So that's the life cycle of a branch. You start out with just one branch here. You make a new branch. You work on it. Other stuff happens. You merge both of them. You delete the special one. And master always stays around, basically. Yeah?
How does git merge resolve contradictions?
What's the question? Oh, yeah. How does git merge resolve contradictions? So if you have different changes, how do you decide whether or not they can both coexist in the same way? Especially if they overwrite the same files in the same lines.
Or like, yeah, if you have the same line of code where you're setting just an integer to equal a number.
Yeah.
And one has it equaling 7 and the other one has it equaling 13. Which one is it?
Yeah, so if there are two lines, or two commits that you merge, and they both have the same change, or different changes in the same place, for example, as a common one. Git doesn't try and be too clever here. If it detects something that it can't automatically merge, for example, Git, if it sees that each of you have modified different files completely, it'll just happily merge both of them for you. It assumes you know what you're doing. So you don't have to do anything special. It'll just know, you touch this file, the other person touched this other file, I can just change both of them in the merge commit, because they don't affect each other, right? You're looking very confused. I don't know if I...
All right, so what if there is a conflict, though?
Yeah.
What does it say?
You just report it
If there is, it pauses the merge and puts special markers in files that are in conflict. I
just point to the conflict.
Yeah. So there's.
Don't worry about it. Just keep
Okay. There'll be arrows, and you can look up the documentation. It'd be a little bit to explain here, but if there are problems, you have to go into the files that are in conflict and make a decision on which one you want, basically. And then you do something called continuing the merge, and it'll finish up. So there's a graceful way of handling the conflicts, but in this way, you usually avoid a lot of those conflicts. Because, for example, if the new feature, all it does is add files, there's no way it conflicts, so it's fine. It just merges fine. But, yeah,
It
good.
doesn't break, you roll it back and do it again.
Yeah. Okay, so the one last thing, you have all these branches pointing at commits, but how do you know what your current branch is? So there's a special reference called head, and it's all caps head. And it just basically points to where you are in the repository, so it is you. So if you're on master, head just has the text master. So for example, I can actually show you here, or I think it's just this file here. So for example, my head right now is refs heads master, so I'm on master branch right now. All this does is, if you want to check out a new branch, the two things that Git will do is update your working directory with the contents of that branch, and then it'll update head so that you know you're on that branch now, basically. You can actually do some weird stuff with this. For example, you could point head at not a branch. You can point it at a special, like an individual commit, and it's called working with a detached head, which sounds much worse than it actually is. But the other thing I want to mention here is something called git reflog. Oh. So these are all the places that head has been recently. So for example, I did the clone and then I made a commit, so head moved. If you accidentally lose a commit somehow, like if I were to can't paste. What? Well, if I were able to paste and I could reset to another commit, I would see that the reflog would update. And if it looks like a commit has disappeared, you can always look in git reflog and the commit will be there magically. And then you can reset back to that commit. So if you feel like you've lost something, check git reflog and you'll be able to reset to it. Here's just a kind of a practical note. You might have noticed that git log looks like crap. This looks awful. Like it's very hard to figure out what's going on here. Oh, I don't know. Maybe that's just me. There's a graphical representation of this, which makes it much easier to understand. So what I usually do is add an alias. So git config global alias dot, and I call it L usually, log, and then there's a few options I like. So I like all, one line, decorate, and I think it's graph. Yeah. So if you look at this, it might kind of look the same as the other one. It's just on one line, but there's a few cool things that this does for you. So it gives you a short version of the name of the commit, which is that hash bit on the left. It annotates commits with what things are pointing to them. So head, the origin master, the origin head, and my master are all pointing at the latest commit here. But if, for example, if you were a head of origin master, they would be on different lines. And also, if a branch diverges, you will see it here as a graphical representation of it. So it'll have little ASCII art arrows and things pointing around so that you can see a graphical version of it. Oh, I lost the... One sec. So that's a personal preference thing, but I find a lot of people have trouble with the Git log normally. It's a much easier way to look at it. And when you want to first start using Git, most of the time you won't have it. If you're on Ubuntu, these 3 lines should get you started. And then you should be able to just use it no problem as I've described here. So this is just some practical stuff for people that might want to get started with it. And of course, I haven't covered everything here. There's the official website, which I linked to earlier. Oh, and I added this page earlier. So Git SCM. And then there's a cheat sheet also, which I linked to here, which gives you just a short overview of all the different commands you can use. And if you want to look up documentation on anything, do man git dash and then the thing you're worried about. So if you are confused about how to use git clone, do man git dash clone. And that's everything, that's way more than you possibly want about it.
And the repo
Yeah.
for this talk is where?
On my GitHub at I'm Scott-Linder on GitHub.
Work on that.
What?
You need to work on the name.
On the name? I'm sorry. I should have been stringy, right?
String was already taken.
No, I don't know why I didn't. I don't know why I didn't go with stringy, but
Create another one.
So expensive though.
It's not.
I know, Artisan. I know it's not.
so yeah, this will be up there. That's all I got.
Did you just do it live?
I just did it live. So I don't know if I've just confused everyone more, but I think there's a good theoretical overview of Git. Of course, you're going to have to use it yourself if you want to really figure it out. But a lot of people go and do it kind of blind, coming from something else or never using a version control system before, and they get lost and then give up on it and just say screw it. So hopefully somebody gets something out of it. Yeah.
I've used it live in program development. We couldn't do the work without it.
Yeah, definitely. Yeah, you'll get to a point where you can't work without revision control.
But you're making a good point that I hadn't thought of. There's a reason to do it if you're coding just yourself on a project,
Yeah,
as well as in collaboration.
yeah. If you're working by yourself, you get history, and if something gets corrupted, it'll tell you immediately. Like I said, because it's a SHA hash of all the commits. So if a commit changes, it knows. There's no way to not notice.
Very workflow oriented, which we
Yes.
so like.
Any other questions?
Who wrote Git?
That's actually kind of a cool. So the Linux kernel developers had an old agreement with another version control system. I think it was called BitKeeper, but it was proprietary. And at some point, they got in this big dispute, and then BitKeeper basically said that they couldn't use it anymore. And Linus wasn't the original developer of the Linux kernel, Linus Torvalds, wasn't about to use anything else. So he just decided to write his own version control system in about a weekend, I think. And he had like basically a working version of Git in like a couple days because he just wanted to prove to people that yes, this is the right way to do it. Of course, he doesn't really work on it anymore. It's been taken over by other people. But yeah, this was originally developed for the Linux kernel. So, and of course they use it now.
And
But
did the price of coffee go up that weekend?
when Linus has a new project, yeah, probably. And also, you can go on GitHub right now, I believe, and there's a repository for Git that has history all the way back to the first Git commit for Git. So you can see the first working version of Git by going to GitHub. I don't know where exactly the Git version, the Git repo is, and you can reset it all the way back to the first commit Linus made when he had a working version of Git. So it kind of bootstrapped itself.
He put Git in Git while he was working on Git.
Yes, put Git in Git while working on Git. That's a good, yeah. And he's a Git. So yeah. So anything else? Any other questions?
One thing, I talked to Smidget a while ago, Jesse Lehman, if anyone was around back then, but Smidget does hiring at University of Massachusetts Amherst, and one thing he mentioned was if there is a resume brought to him that doesn't have a GitHub or any place that like you can look at a sample of your code, like they'll just throw it straight in the trash because no one is going to be interested in taking a chance on you if they can't even look at your code. You can say that you do all the things in the world, but it's a very expensive thing to do hiring. So if you are interested in having a job one day, you may consider everything that Linder just told you, and also starting your own GitHub account and committing to it. Just my 2 cents on getting hired.
That is a good point because the last interview I went into, they looked at my GitHub profile, so it is definitely a place where employers are going to look.
Also, a project management software one was good one to have on there.
Project management?
Yeah.
Talking
Along
like
with the resume.
Redmine or something like that.
Yeah, I can't think of the latest one right now, but I mean, it was mandatory that it's.
Straight up Microsoft
You're looking for people. You have to do Git and you have to do this, so.
Yep.
Any more questions for Scott?
Why are you so sexy?
Oh, I don't know.
I think Harrison's got one.
After
the hair.
Can we watch Hitler use his Git?
God damn it.
All right. Thank you for sitting through that.
Thank you.